Okay. Um, Without the way and sort session. Okay. Okay. So I think I was on to which function? Okay, sorting the keys, byte 1 and 2 index sorting the keys. Okay, try. Okay, I want to dissect this function right here. And what exactly is it doing? Right. Okay, so let's curiosity dissecting dissecting the sort function. Okay. Okay, so okay. Okay, so yeah, offset. What is this offset? This array will hold the count occurrence of all the values of byte. Right, byte off. And I use byte off. Okay, it is equivalent to byte of j plus 1. Byte of equivalent to, okay, these two steps. Byte of equals to byte with offset. Offset to the byte. Okay, this array will hold the count occurrences of all the values of bytes 0 to 25. 255 contains a specific value from 0 to 255. I think I have implemented Radix sort somewhere and I would like to put it side by side, right, right here. Okay, so in Radix sort we find the max, which I don't need the max because the max is, I feel like the max is 256. As we create the max, right, k plus 1 output again. So I know that the max is 256 and we create that array. Maybe I can shift it into another view. Which one should I shift? Move document to other view. Yeah, okay. So find the max, which I don't really need. Array count and output. Okay. For the count array, set all digits to 0. We did. Obtain the count of each key in input array. Count occurrences of every byte. Right now here we are. How many times a byte is occurring? If you obtain the count of each key, let's see, there was something MST or LSD, least significant digit or most significant digit, if I'm right. Yeah. Huh. Radix sorts can be implemented to start with the most significant or least significant. Okay, to start with most significant one or least significant. So So am I using okay LST following sorting order. Short keys come before longer keys. Yeah. So right. This is uh, debug purpose. Debug purposes. I have not completed HTML forms. Didn't okay. Then we transform count. Now see. Now we convert the positions to indexes, then simply return the sorted array. Okay. I take transform count into index by summing. Do I sum? I don't think I sum. Well, I sum, yeah. Okay. So we sum some elements and storing them into same array. Fill destination with the right values in the right place. And I have see this filling. It is doing in the right order. I'm doing it in the reverse order. Right. So there's something with this. In the right place. Right. Okay, so that is the main difference here. That yeah, I will get into details of these. I don't really get that, but okay. See, I get the sum. Right, obtain the prefix sum of the occurrences of the keys in the count array, which obtains the position of the elements in the input, where the position should be. Right. So I set the positions. This is the sum and sum. Okay, so let me write this function as an int. Right. So let me document to other view. We write a function and radix sort. I will do for unsigned not 64 unsigned 8-bit integers. Okay, so I will only have values 8-bit. What is that? What does that give me? 8 bits. A byte can have values from 0 to 127. Okay, so we got short offset unsigned 8t. Okay, this is the max. 8 we have a source and we have a destination, and that is all the function requires. So now I create 256 bytes. 64-bit 8. Okay, let's just did I don't need offset, right? I just need to see what this function is doing, so I will convert all of it into int, right? Okay, we don't need the offset, we just get with int max. Right, what is the max value? We go int source, int test, these are pointers. Okay, max is the limit, right? Max every byte, so we start with the source and we check up to the end. Speed should be less than end, but I don't know end. So end equals source plus max. Okay. What are we passing? Source plus max, max as in where is max, and max equals max size g. Okay, the size of the array. Max is the size of the array. Okay, so I need to create okay, unsigned and yeah, since it is unsigned int, let's use a char, but okay, listen, it is easy to use an unsigned int 8. Okay, so it's another destination and a max. Okay, so okay, these are the all possible values of each byte, right? We have a count array of 256 values or to a 0. Okay. All possible byte values, that which byte have either 0, either 1. How many bytes have these values? How many bytes have those values? Okay, it's done. Then this is the count pointer, just pointing to the count at. Okay, so we create a count pointer. Okay, it's source pointer pointing to the source, and points keeps us in bound. Okay, I assume S is the sum. S is the sum. Yeah. And C is just some temporary thing. Okay. Okay. Source pointer pointing to the source. Okay. Okay. Keeps us in bounds. So, accessing for obtaining the cumulative temporary variable. Okay. Okay, so I have that. Now count occurrences of every byte value. Okay, right. 8 bytes. So there is no offset. I don't have to divide it. So byte, I can just obtain the byte value using this byte, and this is the offset. So I just have to obtain the value of the byte. Okay, count occurrences of every byte. This is a simple Radix sort work. We have an array. Okay, so okay, we'll point to this. Okay, this is supposedly an array. This is a destination array. Okay. Supposedly an array. Okay. So we max. If we like max, or I can max is basically the size of source array or the number of elements. Right. Yeah. That's that. Okay. Source is supposedly an array, so we will go through it and find how many to it, find which value of byte occurs how many times, like a histogram. Right, so for sp equals source, sp equals source, and equals source plus map. Right, then sp should remain less than and it will go sp plus plus. Okay, then in the count array I'll go sp of offset. No, I can obtain the value, right, and increment it. the value of the byte, but I would also have to increment that. Right, byte of, okay, but I am incrementing SP, so I won't be needing that. So obtain the value of the byte and increment the increment its count occurrence. मुसाफिर की तरह. Oh mama. Okay, so this part is done right here, right? That's it. Then I go transform count into index by summing. Now I don't get this. Let's say that we have to bring a cumulative sum of the values. Hana? Okay. Come after a break. Okay, boys. Now we are back. So, looking at this, I understood something, including some of the values. So what this is doing, we start with the sum 0, right? And CP equals whatever the base count of count plus total element. So yeah, okay, that is the, and then we say that CP should be less than end, which makes does it make sense? Should be less than end, and does source plus max. CP should be less than end. Okay, and then we increment count, then we increment the count point. Okay, so we said that CP equals count, and oh, okay, that even makes sense. That and is count plus 256. So basically, yeah, okay. So this is count, and this is count plus 256, right? So then we store a value, whatever the value there is in the count array. Then what we do is, whatever the value we have, we overwrite it with sum. Currently s is 0. Okay, then we include that value here. So see, so what basically is happening is, what basically happens through this is, let's say we have this count array, right? This is count, right. I have my CP here, right? Pointer. I say this is 0, 1, 2, blah blah blah. Say I have a value 0, let's say I have value 3. Okay, now what I'm doing, I'm storing the value of since we are converting them to indexes, so the first value is bound to be 0, right? Really, so let's say I have 3, so in the C I store CP, hence C equals 3. Then I overwrite the value of CP to be S, since currently S is 0. Therefore we get, so a new count would look something like 0 at 0 and all. Okay, So these are indexes, these are positions. Store S, and then in S we increment the value of C. So now S contains 3. Okay, so now S is 3. Again, whatever the value 1, S say 2. Okay, now CP has value 2, C has value 2, and this has this value, which is 3. So it got added, and so 3 plus 2, then this will be 5, and so on. Okay, so that's what this is doing. So basically, how can I write it? This is sets count of 0 equals 0. This piece of code sets count of 0 equals 0 and count of I plus 1 equals count of I plus count of I minus 1. Basically what I did right here, right, okay, there we go. So instead of starting at I equals 1, we started with 0, and that's it. Okay, so however, now fill destination with right values in the right place. Okay, now what okay, so I have to map the indices to their what used to be. Now we convert the positions to indices, then simply return the sorted array. Okay, map the indices to their respective position. Right. Map the indices to their respective positions. Right. And how does this do that? Okay, so we start with for sp equals source and end equals source plus max, and sp should be less than end. Okay, sp plus okay. So we're incrementing the source pointer. Now pointer we get count plus sp of offset or just quite off, right? So it needs values of sp, basically value of source pointer. Okay, cp equals count plus the value of, okay, so now what does this do? Bro, it does too takes too much. It uses too much of my brain. Okay. Okay, so we say count pointer. Okay, and then what I did is count pointer count plus value of sp, because I was doing value of sp, right? Okay, with value of sp. Okay, then in the count plus, now I'm pointing to an element, source element, base address plus this. What would this give me? This is count now, right? So base address plus whatever the value, that is the byte, that is my byte, that is my element. Okay, we need another break. almost there. So we are finding the element, right? Whatever the value of the element is, right? I used to do the same here, right? We get the element in the original array, then we find that element and convert it, and see the positions are already converted. No, the positions are not converted. Okay, but this is going in reverse. We are not going in reverse. What we are doing is, okay, we are finding that value, right? We are finding that value in the cumulative array, right? Okay, count plus, and then at that value of the destination array, I div, and I am incrementing the value of the pointer. I don't get this. Discuss it later.